All right, so example number 8 is going to be dealing with finding a data point, or finding a data point here. Now, a manufacturer of microwave ovens has determined that the mean life of their microwaves is 6.8 years with a standard deviation of 1.3 years. So that means on average, a microwave is going to last 6.8 years. So half the microwaves will last more, half will last less. Okay, some will last way longer, some will last way shorter, but the majority are going to be right around that 6.8 years. And we have a standard deviation to kind of represent where that majority is going to line up. Now, the microwave company or the manufacturer wants to offer a warranty for those microwaves that don't last very long or that kind of bust out really quick. And so, but they don't want to repair any more than 1.5% of those microwaves, or they only want 1.5% of the microwaves to be on warranty. That means that bottom 1.5%, okay, those like kind of anomalies, those they'll help fix on warranty. The rest of them, no, they don't want to fix those, okay, because they want to make sure that you keep buying microwaves. They don't want to fix all their microwaves because they would never make money. So we want to try to find what is the data point which gives us 1.5% of microwaves based on our mean and our standard deviation. Okay, so we have our mean right here, 6.8 years, and we have our standard deviation right here. We're looking for the data point, and we need a Z-score. This, not a Z-score. Okay, that right there is a probability. And there's our probability. And that probability is the same as 0.0150. Okay, so our probability is 1.5%, which is the same as 0.0150. We divide it by 100. We got to figure out what our Z-score is, because if we want to find that data point, okay, and this goes back a couple lessons to when we looked at how do we manipulate our Z-score formula. We know that our data point is equal to our Z-score times our standard deviation plus X bar, or mu. Okay, depending on what we gotta give. We have our mean right here, so there's our X bar. We have our standard deviation right there. We need to know what is our Z-score, and our Z-score is associated with a probability. Okay, this is not the Z-score, not the Z-score. This is definitely not the Z-score. We need to find what Z-score gives us this probability. So let's go to our Z-score table. We're looking for 0.0150, or if you want to say 150, you can think of it that way. Okay, it starts really low. We actually start on this end here, we start at 2, and then we go up and we see 3, and then 4, and then 5, and then all of a sudden it starts going up way quicker, and we want to try to find where is the 150 mark. Okay, where's the 150 mark? And the 150 mark is right here. Let's get the transparency a little bit better here. There you go. There is the 150 mark right there. Okay, there's the 150 mark. Now that 150 mark is based on this row right here, as well as this column right here. Okay, so that's where our 150 mark is, okay, or the 1.5% mark is. So we're going to use the Z-score that is related to this row and this column, which is negative 2.17. Negative 2.17. So we can say that, and I'm just going to kind of write this out a little bit more here. 1.5% is equal to 0.0150. When we find our Z-score, that has a Z-score of negative 2.17. Okay, so this probability is related to this Z-score. Okay, so this probability is directly related to that Z-score. Remember, every Z-score has a certain probability. This probability has this Z-score. Okay, they're related to each other, and we can go back and forth and find each one. Now that we know that, we can solve for our data point. We have our Z-score, we have our X bar, and we have our standard deviation. So we're going to say that X is equal to a Z-score of negative 2.17 times a standard deviation of 1.3 years And then we're going to add 6.8 years onto there. Okay, so we have our z-score times our standard deviation plus our mean. And this is going to give us an x that is in years. So we get negative 2.17 times 1.3, and then we add 6.8. And so we get 3.979 years. Okay, what this tells us, now if we round this to 2, it's going to be 3.98, or very close to 4. It's very, very close to 4. Okay, what it's telling us here is that this is our data point which represents the 1.5%. So it means that, and I'm going to use a different color here, the microwave company, microwave manufacturer, should offer a warranty of I'm make sure try to spell it right. It's not the one I wanted. Of less than 3.98 years. Okay, so they should offer a warranty of less than 3.98 years. If they're going to try to make that nice, they'll probably say 3 years, which is way less, or they would probably say 4 years, which would give them a little bit more than 1.5%, but this is the value that they have to look at. 1.5% of their microwaves are going to die within 3.98 years. Okay? That's what it's telling us. And if they want to fix that percentage, they should offer that warranty of at least that. Okay? If they're willing to fix that percentage, they should be willing to offer that warranty. And that gives us an idea as to how we can take a probability and associate it with a data point.